Good morning, or afternoon, or evening, or whenever you're watching this. This is lesson 3.2 with Mr. Waz. So, as you can see, I'm in my book with it today, or I printed out a sheet with it. You can use your actual book. I liked how this one was done, and I want to talk about a couple of things in here as we write and solve inequalities, as you can see up top there. So, when we look at this, the first thing I want you to think about is, what would you say if I said I have at least $20? Okay, so I want you to think about that for a second. Pause if you need to. If I have at least $20, that means I could have 20, or I could have 21, 22, 23, 24, $500. None of this is true. I think I have $2 in my wallet. But if I have that at least, what throws us off with this, if we're thinking about inequalities, is if I was going to write this as an inequality, you'd say I have greater than or equal to $20. Okay, now let's think of it the other way. If I have at most $20, that means the highest amount I have is 20. This is more of a true statement for my wallet right now. Then I could have $19, $19.99, $2, which is the truth, $5, but I have less than $20. So what throws us off is at most really is a less than or equal to, and at least is a greater than or equal to. So our brain sees least and we think less and we want to make that sign. I suggest anytime you see ones like this, go back and think of it in terms of a at most in your pocket, at least in your pocket, and that'll give you a better idea. Okay? So as they talk through, like with this puppy problem, I'm going to shorten it up a little bit to make it a little bit quicker, but it's saying, okay, first, write an expression for the amount of money they will spend and the number of toys they buy is T. I'm going to change that to X. T's look like plus signs. So if you read, they say they find a bargain barrel containing toys that cost $2 each. So each toy would be 2x. So they're leading you through the process. Sometimes this gets more confusing because we want to just write out an equation right away. Then for letter B, again, they make it more confusing than they need to. They say Chloe has $30. Charlie has 1/3 of that amount. Sometimes when I see those in words, I like to write them as a actual number or fraction. So a third of that, a third of $30 is really just the same as saying 30 divided by 3, which is $10. So total, they have $40. Okay? Now, they're buying toys and they also know they need a new bag of food. So when they're looking at how much they need to spend, I'm going to go to the side and I'm not going to worry about 2 or 3 different methods of looking how to find it. If I want to write myself an inequality for it, I know that I have at most $40. You cannot spend over $40. So going back up top here, at most meant I can have less than or equal to. So whatever I have as my equation, I have to have less than or equal to $40. In this case, I know it's $2 per toy plus $7 for the bag of food that they had. Now, the other part that they go along with this on other pages is, well, what if I want to find out then how many toys I can buy? And we're assuming like no tax, or this is like Indiana or somewhere that doesn't tax you like Illinois does. So if I wanted to solve this, it is just like solving an equation. This is my divider line. We're going to add one other step when we do it in a moment. But if I want to get x by itself, I subtract 7 from both sides. So I get 2x is less than or equal to 33. If I want to get x by itself, 2 and x are attached by multiplying, I divide. So x is less than or equal to 33 divided by 2 would be 16.5. Now, why am I using a decimal here? It's a real world problem. You could use 16 and a half if you want to write it, but that makes sense. So when I think about then, the other part with inequalities we have to be careful of is it says I could have less than or equal to 16 and a half. However, if you have a dog, I do not. I'm allergic to like all animals. But if you have 16 and a half toys you could buy, that's what X represented. Can you really buy half a toy? No. So when if you're going to say, well, give me a number of toys you could buy 16, you could buy 15, you could buy 14. You can't buy half a toy, even though in the solving of the equation, it tells you that. This is the difference between computers and you as humans. A computer could solve this. We could put it in and find a way to solve it, but you know that I can't buy half a dog toy. A computer would not know you can't buy half a dog toy. Okay? You'd probably get in trouble if you tried to go in the store and just rip it and say, here I go. All right. I'm going to skip ahead here to this work here, and I'm going to show it on the side because this is the one other step we have. We have negative 2x minus 4 is greater than 8. So there's one other thing that happens. Normally it's our 5 steps. One, are there parentheses? No. So no parentheses, don't distribute. Do I have like terms? Nope, because on the left side, negative 2x and negative 4 are not like terms. On the right, 8 is not a like term. So no like terms. I don't have variables on both sides, so I go to step 4, move anything, any constant, by doing the opposite function. So minus 4, I add 4. So I get negative 2x is greater than 12. Now, I'm guessing almost all of you would be like, oh, I know the next step, it's divide by negative 2. And you are exactly right, because it's attached by multiplying. However, this is where you need to stop for a moment, and you need to flip it. What do you need to flip? The inequality. When you divide by a negative, this inequality that was a greater than now becomes a less than. Okay, so this is your only new rule. If you divide or multiply by a negative, you must flip. I yell it purposely so you remember it. The inequality. That is the only thing that is different from solving inequalities compared to solving equalities. And you could even think if this was an equal sign, you flip the equal sign. Well, if you flip an equal sign, okay, I flip it the other way, it's still an equal sign. But when you have inequalities, it makes a huge difference in your answer. So now it becomes x is less than negative 6. Okay, so I'm going to just take a look at a couple more here going towards page 41 where it says try to solve these inequalities. Okay, so I'm going to just go through some of these quickly. Have here, want to move, no parentheses, no like terms, no variables on both sides. So I want to move the constant. It's positive 3, I subtract a 3. 11 minus 3 is 8. Going to rewrite over here. Negative 4x is less than or equal to negative 8, or sorry, positive 8. Getting copyright. Divide by negative 4. Flip it. Flip before you do anything else. It just gives me that reminder saying, okay, I divided by negative. I flip it. 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 X is greater than or equal to 8 divided by negative 4 is negative 2. Okay? All right, let's do one more with it. As again, the process is exactly the same. So let's look here. 2x, or 2 distributed, gives me 2x plus 10. Okay, 8 distributed gives me 8x minus 24. Now, I want to talk something briefly because I just thought of a common mistake people make. When you subtract, notice nothing flips. You only flip it when you divide or multiply by a negative. That's it. Only when you divide or multiply. Okay? So here now I do have variables on both sides. I'm going to move the smaller one. So I get 10 is less than 8x minus 2x is 6x minus 24. I have a negative 24, so I need to add 24 to both sides. 34 is less than 6x. Okay, I divide both sides by 6. You're going to get a fraction, and that's okay. I'm going to rewrite it up top here in the order that it is. So 6 goes into 34 5 times, or I could leave it as, let's leave it as 34 divided by 6 and divide them both by 2 because they simplify. So I'd get 17 over 3 is less than x. Now, usually we don't write it that way, and some of these you're going to be asked to graph. You can see the one that's still above there that they gave as an example. You're still going to graph that. But if I want to graph this, I like it with the x first. This one, I am going to rewrite it with the x first, but the opening stays the same. So the opening is towards the x. The alligator's eating the x. So x is greater than 17/3. So this, I would say, is a rewrite. It's not a flip. Flips occur when you divide or multiply by a negative. Okay, I've yet to come up with a song yet, but if you know Michael Jackson songs, Beat It, Flip It seems to go well with that. Flip it, just flip it, but nothing really goes after that. Divide by a negative or multiply with an inequality and flip it. So if that helps you, you can remember that song. If not, just yell it yourself right away. When you divide or multiply by a negative, flip the inequality. Other than that, everything else is exactly the same.